Good day, good day, good day. Welcome to our physical science lesson. Today I'll be covering the factors which affect the rate of reaction. Remember in the last video, we covered the ways and also we defined our rate of reaction, and also we explained how we can measure it and how we can calculate using the graph. So today I want to cover the factors which affect the rate of reaction. And if you're new to the channel, please, I will advise that you subscribe and then go through the playlist, because we've got 3 different playlists. The first playlist is for maths, second one is for life science, and then we also have got one for physical science. So go through each playlist and then you will see different sections that we've covered so far. So today, without wasting time, I'm going to go straight to the factors which affect our reaction rate. So I'm going to cover 4 factors. The first one will be the concentration, then temperature, then surface area, and then catalyst. So I'll go through these factors one by one. And then on another video, I'm going to explain how collision theory relates to these factors. So today I'll just cover the factors as they are. Then on another video, which will be the following one, I'm going to explain how collision theory sort of like is linked to these factors each. So the first factor I'm going to focus on, as I mentioned, is the concentration. So you must always know that the higher the concentration, the faster the reaction rate. So if I were to use 2 different concentrations, let's say I'm going to use 3, and then I'm going to use 4 concentrations each. Remember, the units will be mole dm as 3. That'll be the units. So sorry for not having the units, but the units will be mole dm minus 3 for the concentration. So if I'm using 3 and 4 as my concentration, now the question will be which one. Let's say the first one is number A, the number A4 is number B. So they're going to ask you a question like, between A and B, which one will you expect to have a faster reaction rate? So always remember, the higher the concentration, the faster the reaction. So 4 is higher than 3. So you would expect B to be having a faster reaction because it has a higher concentration. So also remember, these are just the factors that, or effects that you must also know. So the reaction rate will of course depend on the concentration of reactants, because if I'm starting a reaction, my reactants must have something for them to start or to prolong the reaction. So the concentration that I'm going to have as my reactants, they will affect my reaction rate, and of course the higher they are, the faster the reaction rate. And then as time, we know, as the reaction proceeds from the last video, as our reaction proceeds, the reactants will decrease with time. So the more the reactants are decreasing, also the rate of reaction will also decrease. So the more reactants decrease with time, also reaction rate will also decrease with time. They always go together. Increase concentration, increase rate. Decrease rate, decrease concentration. They go together. Sharp. So now I'm going to go to temperature. Same thing, temperature also. It's an directly proportional relationship. So the higher the temperature, I'm going to put T as my temperature, the higher the reaction rate. So they go together. The higher the temperature, the higher the reaction rate. At a higher temperature, you'd expect more particles to have more kinetic energy. There'll be more movement because the temperature will, you can even see when you boil water. If I'm boiling water, there'll be a higher reaction occurring in my water due to the temperature being increased. Even if we go to plug a kettle at home, because now it's winter and it's freezing, most of us are drinking tea nearly every day. So the more when you're boiling water, you will see that there's a way faster movement of water in that kettle. That will be the reaction rate. So the temperature is being increased as the level of power goes up. So the more the temperature is increased, then the reaction rate also gets high. It's also the directly proportional relationship, just like concentration. So remember, if I'm having a classroom has got different sides. I can have a classroom this small. I can have a classroom this big. For example, if you go to most public schools, you find a classroom having like 90 learners. You find a classroom having 90 learners inside. Then if you maybe go to a private school, find a class having like 15 learners. So between these two classes, you can see if something, sorry for saying this, but if something was to happen in a class, these ones are more likely to move freely in the class because it's bigger and there's more space for them to move. These ones are going to end up squashing each other because of there are so many and there'll be overcrowding. So you can see the more or the smaller the people are, this gives them more surface area to move. Because this 15 will have more surface area to move. So the class will be the same size. So let me also show. This will be the same class size. So this is our class size. And then we've got this one to R15 just here. And then I've got another same class size. I'll use the same class size. And then we've got this one to R90. This is how they're covering the class. So you can see there's not much space for this whole learners to move around. They have more surface area to move around. So always remember, the smaller the size, the faster the reaction. So the smaller the size, the faster the reaction. So whenever you've got a smaller size, the faster the reaction. So there'll be more movement for them to move. The bigger the size, the smaller the movement. We can even use a stone. If I were to put a stone, let's say a bigger stone and a smaller stone, you can see that they two won't move the same. The smaller one will move faster. This one will be big. It will struggle to move. It will be too heavy for it to move. So always remember, the smaller the size, the faster the direction. The bigger the size, the smaller the direction. That's how the surface area affects our rate of reaction. So the last one now I'm going to focus on is the catalyst. I think from grade 10 when we're doing enzymes, because they taught us about enzymes in grade 10, about how enzymes speed up reaction. So enzymes, remember, they're catalyst. So always remember, catalyst will always speed up a chemical reaction, and then it does this through lowering the activation energy. For example, that point, we call this point at the top here. I used to call it the top of the mountain. Okay, I still call it the top of the mountain. This peak here, we call it the activated complex. That's our activated complex. And then the point between there and there, we call it the activation energy. So most they just prefer to call it EA, which is the activation energy. So this point here, the catalyst will always lower it. This is my first one, then I have another example. So in my example now, whenever they lower it, now let's say this new one, I'm going to put this line here. So now there's a different activation energy. This one was from here to there. Now this one is from there to there. So therefore, our activation energy has been lowered. This is done by the catalyst. Whenever they ask you the function of catalyst, it is to speed up the reaction. It does this by lowering the activation energy. So now the next thing I'm going to cover is the collision theory. So the background of the collision theory is that particles will need to collide for a reaction to occur. Because if you put things in a beaker or in any source and you expect them to have a reaction, for them to have a reaction, they must collide. And always note, not all collisions will result in a reaction. Not all of them. Some won't. So there are two ways that the reaction will occur. So remember, not everything will cause, not all collisions will cause the reaction. There are two ways that will cause the reaction to occur. The first one, the particles that are colliding, they must have activation energy, which I just mentioned now. For the particles to collide, they must have a good activation energy. And then also for definition, because I know they're going to ask for the definition as well. So the activation energy is the minimum energy that is required for the reaction to take place. Now. So always remember, that's the first point. The particles which are colliding, they must have activation energy. The second point for the reaction to occur, the reactant, they must always approach or meet each other with what we call proper orientation. So they must be in a good orientation. So if the other one, it has got a, let's say, space like this, Right, put a hard space. The other one also must come with a good orientation, which will allow it to bond with this one. So they must bond with each other to a point where the proper orientation will okay. So they must always meet in a way that the two of them can okay. For example, like the key model that we did for enzymes, there's a log and key model we did. I think for Gretens, there was a key model like this one. So for example, the key will need to come and fit in a nice way for the enzymes to work. So same thing here, the correct orientation must okay. For the two particles to collide, there must be a proper orientation. Those are the 2 points you must know: efficient energy and proper orientation, for us to have a collision theory. So also remember, the collisions to occur, they must be effective. So for effective collisions, these are the collisions that will always occur due to the chemical reactions. So whenever they ask you for effective collisions, those are the collisions that will occur due to the chemical reaction. And then always remember, the higher the number of effective collisions, the faster the reaction. It's as it goes that way. The higher the collisions, the more the reactions. And remember, two ways must occur for the collisions to occur. The particles colliding must have activation energy. They must also align in a proper orientation. So next lesson, I'm going to talk about how collision theory relates to the 4 factors we did in the other video. And then also we'll just do some questions to see how they'll be expecting you guys to answer. So again, please subscribe and go through our playlist as it is. And then for this lesson, that will be all. Thank you very much. Koribu Amanda.